Hello students, the topic is pattern of osmotic response of earthworms in heterosmotic media. Pattern of osmotic response of earthworm. Animals tend to maintain an optimum osmotic concentration, that is isosmotic concentration for a given environment. When after a period of hydration, they are returned to a normal environment. Water is taken up, and when after a period of overhydration, they are returned to a normal environment. Water is lost until the osmo concentration reaches the optimum for particular animal. The time course of recovery of water balance from the deviated state may be characteristic of a given species. The mechanism of homeostatic rehydration or dehydration include sensory devices, neural hormonal coordination and behavioral effects. There are two extreme responses of animals to osmotic stress. Animals may osmotically labile, that is, or dependent, and their body fluid concentrations may change with the medium. These are called osmoconformers or poikilosmotic. Other animals are osmotically stable, that is independent, and when the medium changes, their internal concentration remains relatively constant. These are called osmoregulators or homeosmotic. In this experiment, the biological material is earthworm and the reagents used are 0.005 normal silver nitrate solution and 10% potassium chromate solution as indicator. Here what we are doing means we are measuring the salinity of distilled water and salt water. So these are the two medium, salt water or we can take tap water also. These two are the medium in which we are taking two set of earthworm and separately we are keeping this earthworm in two different media. After 30 minutes, we are estimating the salinity of both distilled water and tap water. Before that, initial concentration of salinity will also estimate in both distilled water and tap water. Have a look on the principle of this experiment. The principle of this experiment is when silver nitrate solution is added to the sample, the chloride present is precipitated as silver chloride. It reacts with potassium chromate and form silver chromate which is red in color. The reaction is shown here. Next we can see the procedure in detail. First we want to estimate the salt content. Pipette out 10 ml of the sample into a clean conical flask. Then add 3 to 5 drops of 10% potassium chromate solution. Titrate the sample against 0.001 normal standard silver nitrate solution from the burette with constant stirring. End point is the appearance of brick red color. Note the titer value till the concordant values are obtained. Using the formula N1V1 is equal to N2V2, we can calculate the salt content in the sample. First, we are estimating the salt loss. For this, select two earthworms of similar size, put it in a beaker containing 100 ml of distilled water and cover with a wire gauze. Take 10 ml of sample in a conical flask and add few drops of potassium chromate solution so the solution will now turn yellow. Titrate with the silver nitrate solution in the burette, tabulate the values. After 30 minutes, take 10 ml of the sample from the beaker and titrate against silver nitrate and tabulate the values. Calculate the salt content of distilled water before and after 30 minutes of introducing the animal. That means before we are taking the initial value and after 30 minutes the value is considered as final. Next is estimation of salt gain. Take another set of animals of similar size and introduce the animal into a beaker containing 100 ml of tap water or seawater. Take 10 ml of water sample, titrate against silver nitrate solution using potassium chromate as indicator before done and tabulate the initial values. After 30 minutes of introduction of the earthworms, Take 10 ml of sample from the beaker and titrate with the silver nitrate solution, that is the final value. From that, we can calculate the salt content of the water sample before and after 30 minutes after introducing the animal. Here, care should be taken to maintain equal time for all titrations and use equal volume of indicator for all titrations. See here, 10 ml of the sample is taken in a measuring cylinder from the experimental medium, and that is taking in a conical flask. After that, adding potassium chromate, that is 2 to 5 drops of potassium chromate indicator solution. So the solution turns yellow color. Then titrate with the silver nitrate solution taken in the burette. In this table, the titer values are tabulated. See nature of water sample like distilled water initial, then final, tap water or sea water initial and final like this. Volume of water sample taken all 10 ml. Burette reading is also noted and volume of silver nitrate used is also given. To calculate, first we know volume of water sample taken is 100 ml for introducing the animal. Time allotted for the experiment is 30 minutes. So here normal titration procedure is used to calculate the normality of sodium chloride. That is N1 V1 is equal to N2 V2. See, that is given. Or the salt content of water sample can be calculated by using ml of silver nitrate used in the titration, the normality of silver nitrate that we know 0.005, then equivalent weight of sodium chloride that is 58.475 and volume of sample taken in the beaker that is 10 ml divided by 10 into 100. See, in the distilled water, initial and final value obtained, so that initial value is A, and from that the titer value is 3.1, then that is substituted in the formula and we got 0.0091 milligram of sodium chloride per liter as the initial. And in the distilled water, the salt content after 30 minutes of introducing the animal is considered as B and the value obtained is 0.0131 milligram sodium chloride per liter. What is the salt loss by animal in distilled water for 30 minutes? B minus A. 0.0131 minus 0.0091, that is equal to 0.004 milligram per liter. So this is the next medium, that is tap water or sea water. Salt content before introducing the animal, that is initial value, we can take it as C, that is 0.0491 milligram sodium chloride per liter. Then salt content after 30 minutes is considered as D, the value is 0.0488 milligram sodium chloride per liter. So what is the salt gain by animal in tap or sea water for 30 minutes? That is C minus D. 0.0491 minus 0.0488, that is equal to 0.0003 milligram per liter. Then we can write the result as this. Total salt loss by the animal in distilled water for 30 minutes is 0.004 milligram sodium chloride per liter. Total salt gain by the animal in tap water or sea water for 30 minutes 0.0003 milligram sodium chloride per liter. Then we want to write the inference. From this experiment, it is inferred that the salt loss take place in distilled water and salt gain take place in sea water or tap water. These two conditions can be tolerated by osmoconformers, but the osmotic concentration should be isosmotic for normal functioning. So in the present experiment, the loss take place in distilled water and salt gain take place in sea water. These two conditions can tolerate by osmoconformers. But the osmotic concentration should be isosmotic for normal functioning. I hope you could understand the pattern of osmotic response of earthworm in different media. Thank you for watching. See you in next class with another topic. Don't forget to leave a like and please subscribe my channel.